In this video, we'll define some new notation and terminology, which are covariance, independence, and correlation, and this and that. So this is just on two random variables, but you can define these things in next chapter for multiple random variables. So for two random variables, the correlation between two random variables is defined by the inner product or mean of product of x and y. The next definition of which is important is the covariance of two random variables, which is the correlation between x minus mu x and y. So you remove the means first from x and y, and then you calculate the dot product. So this is called covariance of x and y. So where mu x is an abbreviation for mean of x and mu y is an abbreviation for mean of y. So if you expand, if you multiply these together, so you get xy minus mu x times y minus mu minus y minus x mu y, and then plus mu x mu y. Now if you calculate mean of that, you get mean of this one, which is equal to this one. You get mean of these, and these. So these three guys, two of them, they will cancel each other, one of them will stay. So you see that the covariance of two random variables is equal to correlation minus product of their means. So if one of the means, either mean of x or mean of y is 0, the covariance is equal to the correlation. We call two random variables uncorrelated if covariance is 0. If covariance is 0, we call it uncorrelated. If this guy is 0, we call it orthogonal. If one of the means, at least one of the means is 0, uncorrelatedness and orthogonality, they are same. Otherwise, they are not same. So from this guy, we deduce that x and y are uncorrelated if and only if mean of x, y is equal to. So if for this being equal 0, so this is 0 if you have this one. So two random variables are uncorrelated if the product of the mean is equal to product of the means. If mean of the product is equal to product of the mean, if you could. So uncorrelated is the property that you could distribute this expectation over these two separately. If you cannot do it, you say correlated. If mean of xy is not equal to mean of x times mean of y, or if this is not equal to that, then we say they are, or we say there is correlation between, or they are correlated. So correlation coefficient of two random variable is basically you divide the covariance by the product of standard deviation. So you could easily prove that rho xy is always smaller than 1, smaller than or equal 1. So it is equal 1 if they are on the same direction, because this is basically cosine of their angle between them. So correlation coefficient is between 0 and 1. So as exercise, try to prove this one using the properties you have. So if you multiply both sides by the sigma x, sigma y, you can show that this is always smaller than 1. For uncorrelated random variables, we have this one. If they are, if two random variables are uncorrelated, so therefore this is 0, so therefore this is also 0. we have this equals 0. Now let us have one example for correlation of two zero mean jointly normal random variables. So this is the distribution of two random variables x and y, jointly normal. Mean of x here is mean of x is equal to the first argument, which is 0. Mean of y is the second number, which is equal to 0. And the third one is the variance. So sigma 2 x is equal to variance of x. Sigma 2 y is variance of y. And r is equal to rho xy is equal to x. Y is equal to r. So this is what you can easily show. So cxy in this example, correlation coefficient is equal to rho times sigma x sigma y, which is calculated from this one. You can basically multiply this function, this whatever you have here, you write this expression, and then multiply it by x and y, and then calculate this integral, okay, from minus infinity to plus infinity, and then the x. Once you do that, you'll find this expression. So this is an exercise. So this is double integral.